Guys, welcome back. Today we'll solve some problems on algebra. First question. The domain of definition of the function y is equal to 1 by log of 1 minus x to base 10 plus x plus 2 whole power 1 by 2 is. So domain we already know, right? So what is the definition of a domain of the function? It is the inputs. So what are the possible inputs we need to find? So if you see log 10 of 1 minus x, so we know this number should always be positive, right? So 1 minus x should be greater than 0, greater than or equal to 0, which implies x is less than or equal to 1. But if x is equal to 1, if you see log 10 and x equal to 1, this tends to log 10 0 goes to minus infinity. Usually what happens is in the definition of function, we don't define minus infinity. We represent like this. So this curved brackets means infinity is not included. So if it is like 1 comma 2 curved brackets, it means the end numbers 1 and 2 are not included. If it is like this, it means 1 and 2 are included. Okay, so this is meaning x is between 2 and 1, and this means it is strictly less than. So you see the difference, right? Okay, so now, so here x can't be equal to 1 because then it tends to minus infinity, right? So x is strictly less than 1. So 1 minus x is greater than 0. So for log, this is strictly positive. It cannot be 0 also. So this is one thing, okay? And then this is nothing but the root function, right? Square root function also we should have a positive number. But here square root of 0 is nothing but 0. So it can be greater than or equal to 0. So what you have, x greater than or equal to minus 2, right? So this 2. But something else also we need to find. We need to consider. So this entire term itself should not vanish, right? So the y itself should be less than infinity. It cannot be equal to minus infinity or infinity, right? So then what you have to do, 1 by log 10 into 1 minus x. This should not be equal to infinity or minus infinity, implies log 10 of 1 minus x should not be equal to 0, right? Because 1 by 0 becomes infinity. So then what we have, 1 minus x is equal to, not equal to 10 power 0. 10 power 0 is nothing but 1. So we'll get x not equal to 0. So we have these three conditions. So x is less than 1, greater than or equal to minus 2, and it is not equal to 0. So what do we write? Minus 2 comma 1. X belongs to minus 2 comma 1 minus 0, right? So this is like subtraction symbol for sets we can take. So minus 2 comma 1 excluding 0. So option D is the right answer. Next question. Given f of t and g of t, if f of g and g of f, if f of g is equal to g of f, find k. So this f0g implies f of g of x, and g of f implies g of f of x. So they are saying these both are equal. First let us try to find them alone. So g of x is nothing but f of 3x plus 2, and this is g of kx plus 1, right? Instead of t you can just substitute x, it is just variables. So f of 3x plus 2 is nothing but k into 3x plus 2 plus 1, and g of kx1 is nothing but 3 into kx plus 1 plus 2. So they are saying these both are equal. So what we have, k into 3x plus 2 plus 1 is equal to 3 into kx plus 1 plus 2. So let's multiply inside. 3kx plus 3 plus 2. So 3kx cancels. So we have 2k plus 1 equal to 5. So 2k is 4. So k is 2. So the answer is 2. Okay, next question. Solve for x. So they have given some inequality and they are asking us to find the range of x. Okay, so we have x square plus 6x minus 7 by mod x plus 4 less than 0. So from denominator, what do we get? It should not be equal to 0, right? Otherwise this term itself will blow up. So mod x plus 4 should not be equal to 0. So we'll get x is not equal to minus 4. And we can multiply both sides by mod of x plus 4. It will not change the inequality because it is a positive number, right? So then we are left with this. Now let's just factorize this, right? Let's factorize this. So we have x square plus 7x minus x minus 7 less than 0. So this is nothing but x into x plus 7 minus 1 into x plus 7 is less than 0. So x minus 1 into x plus 7 is less than 0. So left hand side we have two terms. Let's say t1, t2, product of them, and it's saying less than 0. So product of two numbers should be negative. When is it possible? When t1 less than 0 and t2 greater than 0, right? When t1 is negative and t2 is positive, then t1 into t2 will be negative, or t2 is less than 0 and t1 greater than 0. So one of the two numbers should be negative and the other number should be positive. Then only the product can be less than 0. If both are positive, then it is ultimately greater than 0, and even if it is both are negative, their product will be positive. So now let us take case 1. So x minus 1 less than 0 and x plus 7 greater than 0. So this gives x less than 1 and x greater than minus 7. So x belongs to minus 7 comma 1. Now let's take case 2. Case 2, what do we have? X minus 1 greater than 0 and x plus 7 less than 0. So we have x greater than 1 and x less than minus 7. So is it possible? If you see in the number line, we have 0 here, 1 here, and minus 7 somewhere here. We are saying x is greater than 1 and x is less than minus 7. It's not or, it is and, right? So which means they must coincide. But there is no coincidence between x greater than 1 and x less than minus 7. So here we say no solution. So we only have these cases. So x belongs to minus 7 comma 1 and x is not equal to minus 4. So let's just check. So they are just dividing into two domains, right? So I'll just write here. So now we can also divide it into two domains, right? X belongs to minus 7 comma minus 4 union minus 4 comma 1. So this excludes minus 4. So now we'll just check for this. So which is nothing but option C. So option C is the right answer. Okay, let's go move on to the next question. If P and Q are roots of the equation x square minus px plus q equal to 0, then they are asking the values of P and Q. So we have x square minus px plus q equal to 0. So there is a shortcut for sum of the roots of a polynomial, of a quadratic equation, and the product of the roots. So if you have this ax square plus bx plus c equal to 0, we already saw the roots are minus b plus minus root of b square minus 4ac by 2a, right? So if we take one root as alpha, let's take the positive root as alpha, so with the plus sign, and let's take the other root as beta. We have minus b minus root of b square minus 4ac by 2a. So what we'll find, what is alpha plus beta? So alpha plus beta, the second term cancels, right? Then we'll have minus 2b by 2a, which is nothing but minus b by a, right? So what is minus b by a here? B is nothing but minus p and a is 1. So minus of minus p by 1, which is nothing but p. Okay, and product of the roots, alpha into beta. So what we'll have, numerator is just like a plus b into a minus b. So we'll have a square minus b square divided by denominator, we just multiply 4a square. So what do we have? 4ac by 4a square, which is nothing but c by a. So p into q is c by a. What is c here? It is q by 1, which is nothing but q itself. So these two equations are very important. So any quadratic equation, if the roots are alpha and beta, then sum of their roots is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square, and the product of the roots is equal to c by a, where c is again the constant term and a is coefficient of x square. So now we can easily solve, right? We have p plus q is equal to p, which implies q is equal to 0, right? And we have pq is equal to q, so which implies q we can cancel on both sides, p is equal to 1. But you have to think, if it is really the case, this is p equal to 1 necessary for this to be true? No, right? So if you take q to the other side, you will have pq minus q is equal to 0. So q into p minus 1 equal to 0. So we only want either q or p minus 1 to be 0. So we already found q is 0. So it is not necessary for p equal to 1. So this is not necessary. So then how you will find the other root? So you have the equation, right? You substitute q equal to 0 here. What you will get? X square minus px equal to 0. So what you have? So x into x minus p equal to 0. So one root is x is equal to 0 and the other root is x equal to p. So p can be anything. Let's check out the options. So here q is not 0, here also q is not 0, here also q is not 0. So only this option is given, and p they have given us minus 2, but with the given equation p can be anything. But out of the option only this seems correct, so this is the right answer. Okay, then let's move on to the next question. So 1 by log xyz to base xy plus 1 by log xyz to base yz plus 1 by log xyz to base zx equal to what? So first, if you observe, all are different bases, right? Here it is xy, yz and zx. If you are able to bring all of these three to the same base, then we can solve it very easily. So how do we do that? If you also notice, whatever is inside the term is same, right? So then we can use our formula we know, right? Log AB is equal to 1 by log BA, right? So in that case, what it happens? Log xyz and top we have xy plus log of xyz to base yz plus log xyz to base sorry here it is xyz, right? We have taken inverse yz and xyz and zx equal to, we need to find this, so let's take this way. Okay, so now bases are equal and addition is nothing but multiplication inside the log. So xy into yz into zx, so this is nothing but log xyz into x square y square z square, which is nothing but log xyz of xyz whole square. But we know this is nothing but it is equal to 2, right? Log x into x square is x of x square is 2. Okay, So the answer is option B, 2. Okay guys, take care. Thank you.